So yeah, thanks for having me and thanks for showing up today. I'm going to just talk a little bit about some nitrogen considerations, specifically nitrate considerations, as we go into 2024 here. So what is nitrogen carryover? Really, it's nitrogen that was applied or supplied during last year's growing season that remains in that soil profile yet this spring. And if we think about, we don't have time to go through a full nitrogen cycle here and talk about different loss pathways, but in general, nitrogen that's been applied to the landscape typically can be lost through things like excessive precipitation, which can induce denitrification and or leaching. And we also see nitrogen being removed from the field and from the soil environment via crop uptake and harvest. Conditions that can result in greater nitrogen carryover from one year to the next would be where our application rates exceed what the crop needed or removed. Our nitrogen timing, our application timing could have been out of sync with when the crop really needed it, therefore leaving some extra behind. And then, of course, drier than normal conditions, pretty well documented that drier than normal growing season and winter conditions can result in excessive nitrate carryover. So it wouldn't be a spring of 2024 extension event without someone talking about drought monitors. So I have the honor today. Really quick, this is all old news to everyone, but starting, May 30th of last year, from left to right, progressing through the end of August, there's a lot of orange and reds and yellows popping up, indicating different levels of drought across the state. And then, 3 more looking at getting into the end of the harvest season and calendar year last year, as well as last week or the week before, looking at the current drought condition across the state. I know, a lot of areas of the state saw a little bit of rainfall come down earlier this week. But nonetheless, was a relatively dry year last year and certainly this winter as well. So why are we talking about this? Really want to emphasize the fact that nitrogen rate does have a significant impact on nitrogen loss potential. Don't need to spend a lot of time on this figure here, but really what I want to point out on the y-axis is residual soil nitrate. So this was a bunch of data taken from Midwestern corn grain nitrogen response trials. So on the Y, you've got 0 to 3 foot soil nitrate. And on the x-axis, you've got kind of a relative nitrogen rate. So 0 is kind of dead center on this figure. Anything with a negative number or to the left of 0 would have been an under application relative to that site's optimum, and a positive number, so to the right of 0, indicates an over application. And we can see that as we apply rates in excess of that site optimum, soil nitrate accumulation really starts to increase pretty rapidly. So why do we point this out? Well, if there's ways that we can fine tune those nitrogen rates that we apply in our nitrogen recommendation tools, we ought to be doing that to try and, number one, help save the farm money, help save y'all some money on fertilizer that you may or may not need, but also considering the environmental impact that we have when we make those N rate decisions. So what tools do we have to help look at residual nitrate, carryover nitrate, and possibly fine tune our rates? And the primary tool that university has in our toolbox is the pre-plant soil nitrate test. So a few considerations of the test. In general, we recommend using this test on medium and fine textured soils. On our coarse textured soils, just with the way that nitrate can move so readily, it's not recommended to be used and interpreted in the same way than on medium and fine textured soils. If the previous growing season and winter precip was less than normal, you might consider using the pre-plant nitrate test. So here we are. And then again, like we had mentioned a little bit before, if we have any indication that our nitrogen application rate last year was in excess of crop need, we suspect that there's some extra nitrate that carried over from last year. We would want to consider using this test. And so the protocol in corn is you would want to go out early in the spring after the frost is out, but certainly before any nitrogen has been applied. And you want to take samples in 1 foot increments down to a 2 foot depth. If you're really ambitious, you can get down to 3 feet, but going down to 2 feet in 1 foot increments is sufficient. And generally, we would recommend you would take 15 cores and mix those 15 cores together to call it a sample. So we're compositing those cores together. And one sample might represent up to 20 acres of area. And so again, just really want to emphasize that, if you're doing the PPNT, you're going to have 2 buckets out with you in the field. One bucket is for that 0 to 1 foot depth. You're going to put your 15 cores from around that field in that bucket. And the other one is for the 1 to 2 foot cores. Each of those buckets gets mixed up and submitted to a lab as separate samples, because we want to know what's in the top foot and what's in that second foot. And so let's pretend like we just did all that work and submitted the samples to the lab. We take a look at table 6.5 out of the A2809 publication, which should be linked in the chat at some point here during the call. This is kind of how we start breaking down and interpreting what our nitrogen credit is based on the PPNT. So on the left side, you see the result. The units of that lab test ought to come back in pounds of nitrate nitrogen per acre. And then on the right is our credit. So you'll see that on the left there, if our PPNT result is between 0 and 50 pounds per acre, we aren't giving a credit off of our base MRT and REC. It's sort of just assumed that 50 pounds is a background amount. If we're between 50 and 200 pounds of nitrate nitrogen per acre on that test, we would take the result minus that background of 50, and that's our credit. And then lastly, if we're over 200 pounds of nitrate per acre, it's suggested, it's recommended that no additional nitrogen is needed. There's plenty there in that rooting zone for this year's corn crop. So not going to spend a ton of time. This is all just really easy math. Just a scenario where we have a high yield potential soil, corn following corn, looking at, if we do the PPNT and find that we can credit some nitrogen, what this bar chart is really just showing is, for example, the first bar on the left, our PPNT result would have been 60 pounds per acre. So 60 pounds minus that background of 50, our credit is 10 pounds. Just putting dollars next to the amount of nitrogen that we could be crediting off of our base rate by use of this tool. There are some things you can do if doing the PPNT sampling and testing just really isn't in the cards. Whether that's time limitations, can't get a hold of the sampler, what have you. It would be recommended that you do use the lower end of that range and N rates provided in A2809. So right now, our nitrogen to corn price ratios are somewhere close to this 0.15. The last I looked up the cost of N and price of corn, we were about 0.13. So in this case, we might consider applying on the lower end of that 150 pound midpoint range. Might look at 140 or 95, depending on what your previous crop and all those things were. So that is something we can do if last year was dry. So this doesn't only apply just for this year. It's other years where the last growing season was drier than normal. You can use that lower range. So to wrap it up, our N rate decisions do have environmental, agronomic, and economic implications. So very important that we do the best we can to really fine tune that on our farms. Given the recent conditions last year and over the winter, it would be a good idea to do the PPNT on your corn ground this spring. And again, you can use the lower end of that MRTN rec if that PPNT is just not going to work out. You can check out the Department of Ag Trade and Consumer Protection website, or contact your local extension connection to find a laboratory in the state that can help you get these samples tested. And I do have to throw a shameless plug in out there for a conservation practice. Consider the use of a cover crop to help scavenge some of that leftover nitrogen at the end of the cash crop growing season. So with that, I am done.